Problem 64, Quantum Mechanics. The question is, given that PR equal to minus IH bar dou by dou R plus 1 by R, the uncertainty delta PR in the ground state psi 0 R equal to 1 by root of pi A0 cube e raised to minus R by A0 of the hydrogen atom is. Here we have to find out the uncertainty delta PR, which is equal to square root of the expectation value of PR square minus the expectation value of PR square in the ground state psi 0. We can solve this problem using the virial theorem. First, let us write the ground state wave function psi 0 r. This is equal to 1 by root of pi a0 cube e raised to minus r by a0, where a0 is the Bohr radius. We can see that this wave function is real. When the wave function is real, the expectation value of momentum is 0. Therefore, we can say expectation value of PR is equal to 0. Therefore, the uncertainty delta PR become delta PR is equal to square root of the expectation value of PR square. Now using virial theorem, we can find out the expectation value of PR square. Before that, let us write the potential in hydrogen atom. The potential is nothing but the Coulomb potential, that is K E square divided by R. That is, V is proportional to R raised to minus 1. We have, when V is proportional to R raised to N, the expectation value of T is equal to N by 2 expectation value of V. Therefore, here the expectation value of T is minus 1 by 2 expectation value of V. Now, what is expectation value of H? This is expectation value of T plus expectation value of V. This is equal to expectation value of T minus 2T, that is minus the expectation value of kinetic energy. Now we can write it as minus 1 by 2m, the expectation value of PR square. Therefore, the expectation value of PR square is equal to minus 2 times the expectation value of the Hamiltonian. The expectation value of the Hamiltonian is nothing but the energy En, that is given by minus h bar square by 2m a0 square n square. Therefore, we can say the expectation value of PR square is equal to minus 2m times minus h bar square divided by 2m a0 square n square, and this is equal to h bar square divided by a0 square n square. Hence, the uncertainty delta PR is equal to root of the expectation value of PR square. This is equal to square root of h bar square divided by a0 square n square, and this is equal to h bar by a0 n. h bar by a0 n. Now, for n is equal to 1, the uncertainty delta PR in the ground state become h bar divided by a0. Hence, we can say that from the given option, option A is correct.